Data compression is one of the essential topics in multimedia. Compression techniques were developed to cope with the problems of limited memory and transmission bandwidth, costly storage capacity, and processing capability limitations. Throughout the decades, development in hardware have greatly improved in terms of computing power, but our demands for processing multimedia data have also increased significantly. For example, we want high-quality video games on a tiny device, and we want transmission of multimedia data in real time. These demands could not be achieved without digital data compression techniques. Having multimedia data compression allows for better, more efficient representation, more efficient storage, processing, and transmission of multimedia data. In this section, a brief explanation about compression technologies that are useful for various types of multimedia data will be provided. Audio, video, and image signals require a vast amount of data for their representation. As we require better quality of multimedia elements, the data demand will increase as well. For example, if 4 bits are used to define a pixel of an image, then it can only represent 2 to the power of 4 or 16 color resolution. But if higher color resolution is needed, then normally 24 bits per pixel is used, with approximately 16 million color resolution. We can see that to compensate for this higher quality, more data will be needed, and eventually it will be a difficult task to store all this data, transport it, and use it conveniently. So what is the solution? The solution lies within some form of compression of the multimedia digital data. In general, data compression requires the identification of redundancy in data. By knowing the redundancy, we can reduce the number of bits used to store and transmit the multimedia data. Compression can be of two types: lossless data compression and lossy data compression. In both categories, there are various techniques with various algorithms. These two methods can be applied to any types of multimedia data, such as text, image, audio, and video. With lossless compression, we can recover the exact original data after compression. It is used mainly for compressing database records, spreadsheets, or word processing files, where we need to recover the original copy. In contrast, lossy compression methods will result in a certain loss. After decompression, the data becomes different from the original data, but close enough. These methods are most often used for compressing sound, image, or video, where a certain loss of accuracy is not noticeable to our ears or our eyes. For most lossy compression techniques, we can adjust to different quality levels. Either we want higher accuracy of data and less compression, or lower accuracy of data with a greater compression. There are a few major advantages when using data compression. The first one, we will need less storage space for data and less time taken to locate and retrieve the data. Since data is smaller, the communication channel bandwidth can be increased. So a sender would need to compress data before sending it via the communication channel, and the receiver would decompress the data at the receiving end. Sending smaller data also means increasing the data throughput. This means more data can be transferred from source to destination at a given time frame. Generally, When compressing data, many files can be combined into one document. We have talked about data compression, lossless and lossy data compression. This compression can be applied to the multimedia elements. The first one we're gonna look at is image compression. Image compression is minimizing the size in bytes of a graphic file, but the compression should not degrade the quality of the image to an unacceptable level. This reduction in file size allows more images to be stored in a given amount of disk or memory space. It also reduces the time required for the compressed image to be sent over the internet or downloaded from web pages. Audio compression is a form of data compression designed to reduce the storage size of audio files. Hence, the bandwidth needed to transmit digital audio streams is reduced as well. Audio compression algorithms are implemented in computer software as audio codecs. As the name implies, codecs stands for compress, decompress. The way that an audio file is compressed and stored is determined by the codec. Some file types always use a particular codec. For example, .mp3 files always use the MPEG layer 3 codec. .wav file is usually encoded with the PCM codec. So don't confuse the file type with the name of the codec. So we can have lossless compression formats and lossy compression formats. Example of audio format with lossless compression method is the .wma files or Windows Media audio files. An example of audio format with lossy compression method is the .mp3 files. Video compression refers to reducing the quantity of data used to represent digital video images. It exploits the redundancies in video information, both spatial redundancies and also temporal redundancies. Spatial redundancy occurs because parts of the pictures are often replicated with minor changes within a single frame of video. Temporal redundancy occurs when successive frames of video display images of the scene or the background, so it is common of the content of the scene to remain fixed or to change only a little bit between successive frames. Most video compression is lossy compression. It means that much of the data before compression is not really necessary for us to achieve a good perceptual quality.